Hello everyone and welcome to our presentation titled Productivity Analysis and Improvement of Concrete Slab Pouring Operation. This work was developed as a part of the term project for CEE420 Construction Productivity course here at University of Illinois at Urbana-Champaign within the Department of Civil and Environmental Engineering. My name is Atharva Nemade and throughout this presentation we'll be taking you a close look at the real world challenges faced during concrete slab pouring and how we can optimize both crew operations and equipment usage significantly to improve overall productivity on construction sites. The goal was very simple: to do a proper presentation and a report to analyze on a site performance data and to propose a targeted and actionable solutions that can align with best practices in construction management. Before diving into the technical part of our presentation, I would like to take a moment and to introduce our team. This project is a collaborative effort by 6 team members, each contributing unique strengths. Myself, Atharva, and I primarily focused on the site observation analysis and proposal development. Pranav, one of our teammates, helped us to gather the data and time study validation. Ishan contributed to workflow breakdowns and labor productivity assessment. Shiva led the observation tracking and the charting process. Mruga specifically focused on coordination diagrams and report formatting. And finally, Raj managed the equipment analysis and crew balance proposals. Working as a team helped us to look at this slab pouring operation from multiple perspectives and allowed us to suggest well-rounded improvements. Here is a quick overview of what we'll be covering in this presentation. We'll start with a brief introduction to the problem and why we choose to focus on the concrete slab pouring operation. Then we'll share the selection criteria for our project site, followed by the methodology we use for productivity analysis. From this, we will walk through the process chart and flow diagram that map out the activity involved. Next, we'll look at the crew balance chart to assess the manpower distribution. We'll then identify the key issues that impact the productivity and present targeted improvement proposals. After that, we'll show a comparative analysis of productivity before and after after our recommendations. Finally, we'll wrap up with our conclusion. Each section plays an important role in building up towards our final insights and proposals for real life improvements. Let's begin with an overview of a slab pouring operations. Concrete placement is a critical phase that requires precise coordination. It starts with formwork setup, reinforcement placement, and then the actual pouring, which includes vibrating, screening, and curing. Teams must coordinate properly with concrete trucks from pumps and skids in real time. Now, when we talk about productivity in these operations, we are really talking about what maximize the efficiency within a narrow window, since concrete has a limited workable time. Now as it happens now as it gets delayed, uh, it results in cold joints or weak surfaces which compromise structural integrity. From a management perspective, begin productivity also means saving labor costs, reducing material waste, and minimizing downtime. However, challenges are common. Therefore, it includes a which includes poor crew coordination, equipment failures, delays in concrete supply, and miscommunication, and even environmental factors. All these issues are seriously affects the productivity and concrete quality, which is why we choose to analyze this specific operation and how we can improve this process in real time. For our analysis, we selected an active construction site which is on the campus and which is currently going on, which is that is the Weimar Hall construction project at the University of Illinois at Urbana-Champaign. This is an academic building, which means it consists of a really institutional development and follow a strict quality and scheduling standards. At the time our observation, the project was on the superstructure phase, specifically focused on the slab pouring operations. This phase involves placing reinforced concrete slabs that form the floor systems of the building. Since these operations are observed time sensitive and labor intensive, they provides the perfect scenario to study productive patterns and identify improvement areas. The site accessibility and visibility also from nearby buildings also allow us to conduct clear time motion observation using Ox Blue camera webcam services by the Clayco, which is one of the contractor who delivered the whole construction site without interfering with their ongoing project work. Now let's talk about why we choose these concrete slab pouring operations for the productivity analysis. Firstly, pouring involves multiple trades and coordination of heavy equipments like mixers, pumps, vibrators, uh, etc., etc., which makes it more complex and a repetitive process. This repetitive nature make it an ideal condition for monitoring productivity trends over the time. Secondly, this lab work is fundamental. Is a funda is a It's a fundamental process. It sets up the pace for all follow-up activities like wall casting and upper floor working. So improving productivity here can positively affect the entire schedule. In terms of crew composition, we observe the team ranging from 6 to 10 workers, which each handles the specific tasks like pumping, screening, and vibrating. The equipment we monitor includes concrete mixers, boom pumps, power grids, and safety setups. The consistent team size and well-defined roles provides a strong base for accurate productivity tracking throughout this lab pouring phase.
So in this slide, we are going to talk about the operation description for the concrete slab pouring. Uh, I will be explaining the concrete slab pouring operation that we have worked on a Wilmar hall project. There, it was a critical step for the building as the floor was on a suspended height, like on the upper levels. The process included formwork setup, rebar placement, concrete delivery and pouring, and along with it, we know that vibrating and curing the slab is the main thing to do, which will gain the initial strength of the slab. Talking about the details of the scope of for this work, it's like the workers need to settle down the formwork in a perfect manner with a perfect measurements, and along with it, after delivery of a concrete, it should be placed on a time so that it doesn't settle down and the strength can be gained. Talking about the roles and responsibility for everyone, so there are many workers involved, like talking about a pump operator. He used a boom arm to direct the concrete, and the laborers and finishers, including myself, handled the hose, spreading the concrete and conducting screening activities, plus finishing on-hand operating. Like the reinforcement workers uh, were prepared the rebar, and then that rebar cage was placed on the slab, and with using manual and powered tools to ensure that the rebar has been placed perfectly on the slab. After that, coming to a supervisor, our supervisor and along with the foreman, they maintain the responsibility of a safety standard. As it's a main thing that during work there should safety should be maintained. No accident should take place which will delay the project or the productivity or the total overall project. Then talking about the last stage, which is quality control. After doing all the things like pouring the concrete and curing and vibrating it, the quality should be maintained throughout the uh, thing, and that's the responsible personal we have maintained. So he conducted a slump measurement with air content and finishes of it. Now I will be explaining about the equipment we used for the concrete slab pouring operation. Now, as we see in the first picture, we have the boom pipe, which is a truck mounted. So it plays a key role by using its long arm to place concrete accurately across the any slab area anywhere on the slab or upper levels. Next is internal vibrator. They are used to compact the concrete and remove air pockets after it's poured, which is essential for strength and durability. Now, coming to the third picture is a screed tool, which is both manually powered. This tool help the level the concrete surface and ensure its smoothness on the starts of a set. Then we have traveling machine, which are used once the concrete begins to set. Like they will cover a large area and help the finish the surface professionally. And finally, is a formwork support system, which are used to hold a concrete in a place while it sets. This includes like the edge protection, the support structure on the bottom of the slab perimeter, so that the bottom of the slab will be maintained. The finish on the bottom side will also be great. So each of these tools are important to keep the uh, pouring of the slab efficient and high in quality. So now we have attached some photography of a concrete pouring operation, like which we have observed through a web camera. As we can see on a right hand side that we have observed on October 16, 2023 from morning 10:30 to 11:45 am, and the temperature was 50 degrees Fahrenheit, which is suitable for a slab work. Now, talking about the wide top-down view, we can see the full layout of a slab, equipment and workers, which are sequenced and they are overlapping occurs between a few crews, between like they were all working on same slab. That's why. And talking about the boom pump operation image, it clearly shows that the pump arm is reaching at the center of the slab and the movement of the hose across the the pouring zone, helping to understand the workflow of the concrete. Uh, and next picture, it's a work cluster and crew activity photo, which shows how different team member like finisher, the supervisor, the worker, the pouring worker, which are interacted on the site. And it also highlights the safety practices, like how the different work zones were staged when they are working together. Uh, we also captured the truck staging area, which helped us analyze the delivery cycle of the idle time, like when the concrete is being poured on a site and it's uh, kept to use for the another day or after an hour or 1.5 hour. And lastly, talking about the slab surface and finishing of it, the vibration was performed, helping evaluate the quality and smoothness of the concrete finish, so that there are no such air pockets remaining on the slab.
This study evaluates labor workflow efficiency during concrete slab pouring. Three key productivity analysis tools were used, such as crew balance chart, which is used to assess individual worker engagement over time, and the next one is flow diagram to visualize the movement of materials and workers across the site. The third one is process chart. It is used to map each step in the operation and detect delays and redundancies. The data was collected using webcam images taken at 22-minute intervals over a 1 hour period. These tools enabled us to identify operational inefficiencies, including the idle labor, material, staging delays, and poor workflow transitions, which will be addressed in these following slides. The first one is crew balance analysis. A total of 12 workers were observed over a 6-time intervals. Their activity status was categorized as their working or idle time. This summary of table shows the utilization percentage of each worker. Spreader 3, 5 and 6 recorded less than 50% utilization, and the vibrator operator was also idle in several intervals. In contrast, spreader 1 and 2 were consistently active, indicating a lack of balanced workload distribution. These findings confirm the presence of overstaffing and role-specific utilization, forming the basis for one of the key problems identified in this study. The second one is flow diagram. This flow diagram illustrates the path of concrete from production to the placement. The process begins at the ready-mix concrete plant, followed by an initial inspection, transportation to the site, and queuing in the staging area. The concrete is then placed using a boom pump, after which is undergoes spreading and compaction and finishing. As a significant issue identified in this diagram as queuing of trucks at the staging area. This delay led to downtime at the pump and impacted the continuity of concrete placement. The third one is process chart, which provides a step-by-step breakdown of concrete pouring operation. Symbols were used to indicate the actions such as storage, inspection, transportation, delay, and operation. Based on this process chart, we identified some key problems such as the first one is the staging delay caused by trucks waiting for the pump availability. The second one is poor handoff between pouring, compaction, and finishing tasks, which led to the idle time for certain workers and an uneven workflow. These inefficiencies contributed directly to overall productivity loss. Based on the
Thank you so
analysis,
much
two
for giving
major
the opportunity to
productivity issues were
explore on
identified.
these
The
topics,
first one
making
is
us
overstaffing
believe
and
on
crew
small
imbalance.
things that makes huge
In this, 12
difference in the
workers were
construction
deployed, but
sites.
only 8
Definitely
were
helps in the
required for
future. Thank
full
you so much.
efficiency. Based on the analysis, Predator 3, 5, and 6 had utilization rates below 50%. The vibrator operator was also idle during multiple intervals due to the lack of communication and coordination. This led to unequal workload distribution and unnecessary labor costs. As you can see the image, there are a lot of workers standing at the single place. Problem 2 is concrete truck waiting and staging delays. Concrete trucks are waited at this site due to coordinated delivery timing. The flow diagram showed congestion at the staging area, delaying pumping activities. This increased the risk of cold joints and negatively affected the pour continuity.
One of the key challenges we identified during the slab pour was crew imbalance. Several workers, especially spreaders, were idle for more than half the operation. This proposal focuses on redistributing tasks among the existing crew to keep everyone consistently engaged. Instead of increasing manpower, we simply improved how the team was organized. After implementing the crew strategy, we saw a major improvement in worker efficiency. Nearly every team member reached 100% utilization, and overall crew productivity rose to 91.67%. What's most important is that we achieved this without increasing the number of workers, just by aligning roles more effectively. This side by side timeline clearly shows the difference. Before, many crew members had long idle periods, especially among the spreaders and vibrator operators. After balancing, everyone was actively working across all intervals, and this simple adjustment helped create a smoother, more synchronized workflow. We reduced the number of spreaders from 6 to 3 and reassigned the rest to support roles like vibration and finishing. The crew was reduced from 12 to 8 without impacting the productivity. This not only cut down on crowding but also improved coordination, making transition between tasks more efficiently.
To overcome the issues during the slab pouring operation for this project, one of our strategical improvement proposal is a crew task reallocation. This assures effective utilization of manpower on site and results in increase in productivity. In upcoming 3 slides, I'm going to discuss about the crew task reallocation. This slide is about general overview of the proposal. Crew task allocation is basically redistribution of specific tasks among the worker on site to enhance the productivity. There are 3 things to be considered for the resource reallocation. First, break down entire operation into small and feasible tasks, and then work in a parallel zones on a multiple task at the same time and overlap activities to reduce the cycle time. Few key advantages for the reallocation in a parallel execution is that it will reduce the idle time and enhance smooth workflow on site. It will help in completing the entire flow in efficient time with optimized use of workers and without increasing the crew size. This all will eventually help in increasing the productivity at a greater extent. This slide shows the comparison between the original crew task allocation and proposed crew task allocation. In this proposal, we are keeping crew size same as before. We have total 12 worker crew for this operation. In the video that we observed for this site is having a one concrete pump operator, one concrete pump helper, 6 spreaders, one vibrator and one finisher. Now for the proposal, we are keeping the concrete pump operator, concrete pump helper and the spreader crew same as before, but we are shifting one finisher from a finisher task to a vibrator task. This slide represents the revised crew balance chart based on the crew task reallocation. In this, we have proposed to work on two zones simultaneously and concrete pump operator and helper will share two zones together. Earlier, we had total 6 spreader and we are splitting them now into them equally into both zones. In the original operation, we had 3 finishers, but now we have only 2 finishers, one per zone, and the third finisher will work as a vibrator. That way we'll have a one more vibrator to perform the task efficiently. Based on the analysis from the previous slides, we can reduce the total cycle time by 25%, and we can achieve this by working on the different zones at the same time and training workers to perform the multiple tasks to avoid the idle time. We can improve productivity by approximately 30% with the better crew coordination.
Material handling seems to be a problem in the construction site we observed. In order to ease the material movement and accessibility during the concrete slab pouring, we observed issues in the construction site that was unscheduled truck deliveries where the concrete supply trucks were not scheduled effectively, and also observed the compact areas for the material placements where the tight layouts of the material caused difficulties in accessing necessary tools on time, so causing delays in the construction. And also there was a problem in the formwork and reinforcement positioning contributed to operational inefficiencies. Summing up the whole idea of improving the productivity in a construction site that we observed, here are some key takeaways. Efficient concrete slab pouring is essential to enhance the overall project productivity and that minimizes the delays. And also, it identifies the major productivity challenges as crew imbalancing and equipment downtime, poor coordination between the team members and resources. And we also went through proposed solutions, the implementing crew task relocations that came up with a good result of reducing time and increasing productivity, and crew balancing and material handling, which aimed to addressing the challenges by optimizing labor utilization and ensuring better coordination. And after doing all of this, the expected impact on the construction side that we made was reducing the cycle time. The proposed changes are expected to reduce the concrete pouring by 25% by all the calculations we made, and allowing the faster project completion and more efficient work environment. And also, we increased the labor productivity by altering, which anticipated to increase 30% of labor productivity and leading better utilization of workers and reducing the ideal time. Overall outcome from this overall report is by focusing on better coordination and improved workflows, the optimized material handling, the project will benefit from the safer and more efficient operations. These improvements lead to enhanced cost effectiveness and smoother execution of concrete slab pouring activities. Summing up the whole idea of improving the productivity in a construction site that we observed, here are some key takeaways. Efficient concrete slab pouring is essential to enhance the overall project productivity and that minimizes the delays. And also, it identifies the major productivity challenges as crew imbalancing and equipment downtime, poor coordination between the team members and resources. And we also went through proposed solutions, the implementing crew task relocations that came up with a good result of reducing time and increasing productivity, and crew balancing and material handling, which aimed to addressing the challenges by optimizing labor utilization and ensuring better coordination. And after doing all of this, the expected impact on the construction side that we made was reducing the cycle time. The proposed changes are expected to reduce the concrete pouring by 25% by all the calculations we made and allowing the faster project completion and more efficient work environment. And also, we increase the labor productivity by altering, which anticipated to increase 30% of labor productivity and leading better utilization of workers and reducing the ideal time. Overall outcome from this overall report is by focusing on better coordination and improved workflows, the optimized material handling, the project will benefit from the safer and more efficient operations. These improvements lead to enhanced cost effectiveness and smoother execution of concrete slab pouring activities. There is two important references that is worth highlighting in order to come up with the whole idea. One is the Professor Ignatius the class no lectures, the lecture starting from 3 to 8, which gave a clear idea of rebalancing and allocations, everything. And the second reference is from Plyco webcam, where we got the data from there in order to get the actual site conditions and also the workers' productivity from there. So these are the two references. Thank you so much for giving the opportunity to explore on these topics, making us believe on small things that makes a huge difference in the construction sites. Definitely helps in the future. Thank you so much.